Hello, everyone, and welcome to this video on Hegel and Newtonianism. This video is kind of a preamble to the workshop that we've organized on Hegel and Newton uh, for the 18th of January 2026. And what I wanted to do was to start the discussion going about Hegel and Newton and Hegel and Newtonianism more generally. And to do that, I have prepared a a small sort of reproduction of a lecture, a talk rather, given by a professor called James W. Garrison. This is a talk that was given at the 1989 Hegel and Newtonianism conference, funnily enough, which was organized by Michael John Petrie and was then put together into a conference proceedings that was published in 1993. Interestingly enough, just a little history, a little backstory to how the scholarship in Hegel studies changed um, in the middle of the 20th century. Up until the 1970s, it was generally thought that Hegel was a bit of an idiot with regard to his criticisms of Newton and science more generally. People thought that Hegel didn't really know what he was talking about. He sort of had the appearance of that sort of armchair philosopher making criticisms of scientists. And then, thanks to the work by people like Michael Petrie and A.V. Miller, who you might know from his translations of the Science of Logic and the Philosophy of Nature, it gradually became more accepted that Hegel was actually very well read up on his science of the day, and he actually understood it quite well. And so people started taking his philosophical remarks and criticisms more seriously. And in the 80s, there were these three conferences. All of them involved Michael Petrie in one form or another in the organization of them, amongst other scholars who also played a role in this. And each of these conferences sort of saw a renewed engagement with Hegel's philosophy of nature, really. That was the text that people were trying to sort of resurrect. And Hegel and Newtonianism is the third and final one of these lectures that were sort of form part of this series. It's not really a series, but they were organized by more or less the same people. Sort of a tradition in the 80s. And it's the first English um, language conference that they organized, so it's slightly more accessible to a wider audience. And it includes 44 talks on a wide range of topics. And I wanted to start with James Garrison's talk, which is entitled Metaphysics and Scientific Proof, Newton and Hegel. It's actually the first talk that is in this collected proceeding. And I wanted to start with this talk because, in it, Garrison talks about three criticisms that Hegel makes of Newton's derivation of the universal law of gravitation. And I think it's a really good. So there are the three criticisms. I'm just going to talk about one of them. And I think this one criticism that Hegel makes of Newton is a really good place to start thinking about how philosophy, maybe more specifically Hegelian philosophy, but I don't think specifically Hegelian philosophy, because as we will see, the kinds of criticisms that Hegel makes, I think, are more, they're sort of, they don't rely on Hegelianisms or Hegel's particular way of philosophizing. It's a more general philosophical concern about Newton's approach. And I think that's a nice way to get into learning more about Hegel's engagement with the sciences. So, Newton's universal law of gravitation, everyone sort of knows about it uh, without going too much into it because currently, if I wanted to, Newton in the Principia eventually derives or believes he's derived the fact that there is a universal law of gravitation, the inverse square law of gravity. We all learned this at some point in our science classes. And Hegel's concern is with the way that he derives this. And this sort of concern falls into two aspects. The first of these aspects has to do with a general criticism that Hegel has of pure mathematics. And more specifically, I think he's got Euclidean geometry in mind. And basically, the criticism is the following: Euclidean mathematics, geometry, it takes its conclusions to be absolutely certain because of the way that they're deduced, right? You get these mathematical deductions that follow from each other. It can all be proven internally. And that gives you the feeling of certainty that what you've deduced is in fact correct. And Hegel is making a very common point, actually. I don't think there's anything very Hegelian or unorthodox about it, which is that, look, you are beginning your deductions with a set of axioms, right? This is how Euclid, in his Elements, for example, will begin. He sets out his axioms, like the shortest distance between 2 points is a straight line, right? Euclid takes that to be self-evidently true. And you can see why. It does seem to be self-evidently true. He doesn't prove that it's true, he just assumes that it's true. And he builds or deduces further mathematical truths from it. And Hegel's concern is precisely is this: it's that you're starting from um, your starting point is taken for granted, and you're deriving things that you're taking to be absolutely certain when your starting point is itself not based on the methods that you're using to derive certainty. Um, the very same deductive methodology that you're using to say that your further geometrical proofs are true is not applied to your application of your axioms. And that could be seen to be problematic. So that's sort of the first aspect of Hegel's general concern about sort of mathematical deductive work. Then there's the more specific concern with regard to applying that mathematical deductive model in science, in empirical science, right? So let's take a step back and let's just look a bit at Newton and what he does. Again, to cut a long story short, and here I'm relying heavily on Garrison's own sort of reworking of the material, Newton does a sort of step-by-step deduction from very low-level observations, like the example of gravity on Earth, to slightly more sort of greater examples of gravity. So he goes from observations of gravity on Earth to observations of gravity between the Earth and the Moon, to observations of gravity between other planets and their moons, and then onto the Sun and the planets in the solar system, and then universal gravitation from there. So he's doing this move from more some sort of safe, low-level observable phenomena to more universal ones, until at one point he simply posits the universality of gravitation, having shown that it applies in all these cases. And again, you can sort of see the logic there. If something applies in A, B, C, D, we can assume it applies in E, F, G, H. Of course, for Newton, it's more than an assumption. Newton takes it to be true, And Hegel's concern is, well, wait a minute, your starting point is itself not provable. The fact that you can show that it occurs in all these other instances where greater distances are involved does not retrospectively make your starting assumption true. So, hold your horses, Newton, basically. Um, so that kind of sums up Hegel's first problem with Newton that Garrison refers to in this lecture. It's just this concern with applying I guess Hegel's concern is that you're importing, I suppose, the feeling of certainty that you get from the mathematical deductive method um, when you're using it in other sciences like physics, right? And you're saying, well, this method gives me pretty good certainty when it comes to geometry. I'm just going to sort of take it out and plug it into this other set of data, which is not, abstract propositions about space, but is in fact based on observable phenomena. And I'm going to sort of be quite confident that I'm going to get the same kind of certainty out of it. And Hegel is saying, well, no, actually, you're not. And then there's also a further concern that Hegel has, which is that the certainty that Newton, so because Newton is aware of what he's doing. Newton is not blind to the fact that it is problematic to be applying the mathematical deductive method to empirical phenomena. And so Newton tries to sort of buttress his deductions by having certain rules. And I'll just give an example of one of three of these rules, which are the ones that Garrison makes reference to sort of explain his point. So one is entitled Rule 1, and here I'm quoting Newton from the Pemberton translation. Sorry, no, not from Pemberton translation, from another translation, which I cannot determine right now. Doesn't matter too much. So, this is Rule 1. We are to admit no more causes of natural things than such as are both true and sufficient to explain their appearances. To this purpose, the philosophers say that nature does nothing in vain, and more is in vain when less will serve. For nature is pleased with simplicity, and affects not the pomp of superfluous causes. End quote. This is basically a reworking of something like Occam's razor applied to nature. If there are two options to explain a natural phenomena, the option which has the simplest mode of explanation will be favorable or be more correct because nature behaves in the most expedient way, let's say. Now, you can see why this would help Newton to justify the deduction of the universal law of gravitation from all the little examples of gravity. Because Newton is saying, well, look, gravity is working here, it's working there, it's working there, it's working there. The simplest thing to deduce from all this would be that it's working like this everywhere. Hegel's point, though, is, hold on. This assumption, firstly, this is an assumption about nature being about nature working in the most expedient way. In other words, in simpler explanations being more accurate representations of how nature functions. This is a metaphysical assumption. You cannot deduce this from sensory perception. You need to defend this claim metaphysically. And just because we're sort of getting, I think this is really interesting, and I'm going to read Rule 2 now, which I think is also quite enlightening. Rule 2 from the not yet determined Newton translation. Therefore, to the same natural effects we must, as far as possible, assign the same causes. As to respiration in man and in a beast, the descent of stones in Europe and in America, the light of our culinary fire and of the sun, the reflection of light in the earth and in the planet. This is actually, I think, is a great quote to connect with the criticism of Hegel the criticism of Newton that we've been talking about, because here Newton is clearly showing that he thinks it's perfectly reasonable to assume that if something works one way in one place, then it will work that way in another place. To the same natural effects, we must, as far as possible, assign the same causes, right? So if an apple falls from a tree on Earth, cause is gravity. If the moon is moving around the Earth, slightly more complicated, and obviously uh, let's not belittle Newton's achievement in sort of noticing this similarity, but gravity, so on and so forth. Um, so here again, we have a metaphysical assumption, which is that similar effects will have similar causes. This is a metaphysical assumption. This is not something that can be derived from sensory perception. You cannot perceive that every single effect of a type will have the same cause every time. You have to assume that. Well, Newton is assuming it, but it's a metaphysical assumption that requires justification. And since we've gotten up to Rule 2, let's just do Rule 3, because what the hell. Rule 3. The qualities of bodies which admit neither intensification nor remission of degrees, and which are found to belong to all bodies within the reach of our experiments, are to be esteemed the universal qualities of all bodies whatsoever. So here, and some of these qualities of bodies that Newton includes are extension, impenetrability, mobility, and inertia. And here again, this is a very clear example of Newton making a metaphysical claim. What is the nature of a body? Newton is telling us all bodies will have these qualities. Why does that matter? Well, it matters because if you're going to make a generalizable universal law of something that applies to all bodies, then it helps to have a constant of what all those bodies can and cannot do, right? Because if you can't assume that all bodies have certain basic fundamental principles that they will all follow, then it's going to be very hard for you to justify that they all behave in the same way when it comes to gravity, for example. So that's sort of an extra sort of little bit about what Hegel is annoyed about with Newton's derivation of the universal law of gravitation. Not only does it work off this sort of applying this deductive method onto phenomena, but moreover, it uses unjustified metaphysical assumptions. It, you have to take things for granted to support the conclusion of the deductions. And what really sort of boils Hegel is that the conclusion is then what justifies the beginning. Yeah. So the derivation of universal gravitation is what then sort of justifies asserting that it's gravity that is working at point A and point B and point C and point D. So that's just a little discussion about James Garrison's paper. Again, it's entitled Metaphysics and Scientific Proof, Newton and Hegel. It's the first lecture of the Hegel and Newtonianism conference in the proceedings. I will put in the description below the full title of this edition. I think it might be available online for free. I'm not sure, but it's really a great collection of lectures, foundational in my opinion, if you want to get into Hegel and science. this conference series, this conference focused particularly on Hegel and Newton, and it's sort of subdivided into various themes. The previous two conferences that were also partially organized by Michael Petrie are slightly more broadly concerned with science and metaphysics of science. Yeah, I think it's foundational reading. If you're interested in this topic, if you want to read more about it, I would highly recommend this. And yeah, please let me know what you think about what I've said, what your thoughts are about this kind of philosophical criticism of scientific method. And I'll be looking to make another one of these videos, maybe a few more, before the workshop on the 18th. Okay, well, thanks a lot for listening, and bye bye.